So welcome to Jumbo IS and welcome to Geography and Environment lecture number 2 of this lecture series called Prelims Powerplay 2026. In this lecture series, we will revise our entire syllabus for UPSC Prelims examination, static portion as well as current affairs portion. You don't have to refer to any PT 365 or monthly current affairs magazines. Just follow this lecture series and everything would be revised. Alright, now just watching this lecture would be job half done, because just after watching this, you have to revise it and memorize it from the notes. Ask your doubts, because as soon as you register for this series, you will be enrolled in our WhatsApp groups where you can ask your doubts anytime. And along with this lecture series, you shall get a test series. Tests are extremely important. They solidify your preparation. Therefore, give the tests on time. Now, lectures would come on YouTube, but for notes, for WhatsApp groups, and for tests, you have to register on our app or on our website. The link to both are given in the comment section below. So if you want to register, well, click on the link given in the comment section. Okay, now let's begin today's discussion. And our today's topic of discussion would be tropical cyclones. You all know that tropical cyclones have been in the news for quite some time, and every year they are in the news. Okay, just after the monsoon season, there is the season of tropical cyclones. Just before the monsoon season and after the monsoon seasons, and even during the monsoon season. Well, monsoon season also is accompanied with the cyclone season, which hits our east coast most of the times, but sometimes it also originates in the Arabian Sea and hits our western coast. Okay, so today we are going to talk everything related to tropical cyclones. You wouldn't have to worry about this topic as far as your prelims paper is concerned, provided you listen to this lecture carefully, you memorize this lecture from the notes provided by us, you ask your doubts, and you give the tests on time. These 4 conditions are very important. Okay, all right then. Let's begin with today's topic, tropical cyclones. Okay, so Geography Environment lecture number 2, tropical cyclones, and here we begin. So the thing is that we all have heard about tropical cyclones. They hit our eastern coast, they cause a lot of destruction, everything. Now first let's talk about the definition of tropical cyclones, and then we'll also take a look at the diagram. Okay, first let's get introduced to this idea of tropical cyclones. Whenever you hear the word cyclone, the image that is created in your mind is this image only. Okay, it's like a whirlpool of winds, very high speed winds, right? Now, tropical cyclones are intense, rapidly rotating storm systems characterized by a low pressure center. So just at the center of the storm is a low pressure center, strong winds, heavy rainfall, and thunderstorms. Now, the reason why we call them tropical cyclones is because they occur in the tropics. Okay. Now, what are these tropical regions? Well, tropical regions are those regions, well, between Tropic of Cancer and Capricorn. Okay. There is equator, then Tropic of Cancer, Tropic of Capricorn. Between Tropic of Cancer and Capricorn is the tropics, tropical region. In the oceans found in this tropical region, well, you will find tropical cyclones all over the world. In the Indian Ocean region, Atlantic Ocean region, Pacific Ocean region. Okay. Now, the reason why they only form in tropical regions is because the essential condition for the formation of tropical cyclones is high sea surface temperature, high sea temperature. So they form over warm tropical oceans where sea surface temperature exceed about 27 degrees Celsius, either 27 degrees Celsius or more than that. This process creates a system of clouds swirling around the low pressure center with a calm eye at its center. So the low pressure center, the exact center of this storm is known as the eye of the storm. We'll talk about this. And the most destructive winds found around the eye wall. So the center of this cyclone is the eye, and winds are moving in a rotating fashion, circular fashion around the eye. That area is known as the eye wall, and that is the most destructive portion. Okay. Let's take a look at the image also. This is a tropical cyclone. As you can see, this portion is the eye, and these winds, the rotating winds around it are, well, the eye wall. Nonetheless, let's first focus on tropical cyclones. Okay. Now, what are the essential conditions? Remember this because an MCQ can be asked. Okay. Which conditions should be there for a tropical cyclone or for the formation of a tropical cyclone? Okay. These 5 conditions have to be met. Only then a tropical cyclone would be formed. What are the conditions? Number 1 is sea surface temperatures exceed about 27 degrees Celsius. So 26 to 27 degrees Celsius or even more than that. Warm tropical oceans. Then the air mass should be moist. And that is why tropical cyclones always form over the sea. over the oceans, because oceans provide the required moisture to the air above the oceans. Okay, air mass above the ocean is always moist. That is why tropical cyclones do not form on land, because there is lack of moisture on land, but not on seas. So moist air mass. Then third, you know why tropical cyclones are, why are they rotating? Because the winds that are moving in the direction of the low pressure area, these winds get turned. Okay, these winds are pulled at an angle because of the Coriolis force. You must have studied about Coriolis force. Now remember, Coriolis force gives them, so if the wind is moving in a straight path, let's suppose this is the direction of the wind from high pressure to low pressure. Low pressure area is the eye of the storm. So if the wind is moving in this direction, well, a particular force moves it in this direction, curves it a little bit. That is why the winds blowing in a tropical cyclone move like this. They rotate. Okay, because they are not straight, they are bent a little. And this force that makes them bend is called the Coriolis force. Okay, so there should be presence of Coriolis force. Now, one thing is very important. You know, Coriolis force is absent at equator. Oceans that lie just at the equator, they are warm, they have moist air mass, but there is absence of Coriolis force. That is why tropical cyclones are never formed over equator. They have to be either 5 degrees north to the equator or 5 degrees south to the equator. More than 5 degrees, by the way. At least more than 5 degrees north, 5, 6, 7, but more than 5 or 5 degrees south. Because at that place, there is sufficient Coriolis force. So this is condition number 3. Then condition number 4 is, well, low vertical wind shear. You see, these winds that approach the eye of the storm, they rise upwards. As soon as they rise upwards, well, the condition is that as they move upwards with the altitude, their speed shouldn't change. If at the lower level their speed is 10 km per hour, at the higher level also it should be 10 km per hour. There shouldn't be that much change in the vertical wind speed as you climb up the altitude. This is known as vertical wind shear, low vertical wind shear. Okay. And how is tropical cyclone formed? So this is a low pressure area. Winds approach it from all directions. These winds converge at this low pressure area and they join together and they start rotating around it and they start to move upwards. Okay, so convergence of surface winds causing air to rise and condense. When they move upwards, they cool down because they have moisture, they condense, okay, they form clouds and rainfall happens. Okay, so these are the conditions. Remember this. These 5 conditions are absolutely important for you to remember because an MCQ can be asked. So number 1 is, I'll repeat it again, okay, it is very important. Warm oceans, moist air mass, Coriolis force, low vertical wind shear and convergence of surface winds. Okay. Now, as far as the basic characteristics, okay, features of a tropical cyclone are concerned, let's just take a look with the help of an image. Okay. So this is a tropical cyclone. So this is a low pressure area. Winds approach to this low pressure area from all sides and they converge and they start rotating and they start moving upwards. So they start rotating around it like this and they move upwards while rotating. This is how a tropical cyclone is formed. The center of the storm, okay, the center, exact center is the eye of the storm. What happens is that when air rises upwards, okay, when this moist air rises upwards, it cools down, forms clouds, okay. When it forms clouds, okay, rainfall happens. But this wind that has cooled down, it descends downwards after cooling down. It rises up, gives up all the water vapor, cools down and comes downwards. This area of the storm, which has a diameter up to 10 kilometers, even 50 kilometers, this area is known as the eye of the storm and it is a very calm area. If you are sitting in this eye, you won't feel a thing. It is very calm. But just around this eye, winds are moving, rotating at very high speed, sometimes even 200 kilometers per hour. This is known as the eye wall. Surrounds the eye with the strongest winds and heaviest rainfall. The diameter of the entire tropical cyclone can range from 320 kilometers to even 1500 kilometers in major, huge storms. Okay, so just remember, though we will come back to the features of tropical cyclone, we will come back to this topic, but I'm just giving you a basic idea how this storm looks. Okay, so this is the eye This surrounding area is the eye wall, and these clouds that are moving outwards, these are known as rotating clouds. We'll talk about this, okay? So this is the thing. Now, what is the formation process? I mean, what are the steps that lead to formation of a big storm? Remember this. So the initial phase, where warm ocean surface heats the air, causing convection and thunderstorms. So ocean is warming up and air is rising upwards, forming clouds upwards, okay, forming clouds at a higher altitude and then causing rainfall, thunderstorms. This is the initial development. Then the tropical cyclone reaches the mature stage, okay, where the cyclone intensifies with a well-defined eye and spiral rain bands. These clouds are called spiral rain bands, okay. And then this tropical cyclones, when it is rotating, it is also moving towards the coast. So it forms in the Bay of Bengal or Indian Ocean, and then this rotating system is also moving towards the Indian coast. As soon as it lands on the coast, okay, that is known as the landfall. So landfall is the event of a tropical cyclone moving from water onto land, specifically when the storm's eye crosses the coast. As soon as the eye of the storm reaches land, that is known as landfall. At landfall, because there is land, there is lack of availability of moisture. And because there is lack of availability of moisture, this storm dissipates, finishes. This is known as the dissipation stage. Dissipation stage always happens after landfall. If this storm is in the ocean only, waters only, it will not dissipate. So when the cyclone loses energy due to moving over land, landform, or cooler waters, when it moves towards cooler waters, dissipation stage. So remember, a storm has 3 stages: initial development, mature stage, dissipation stage, which is generally after landfall. Simple, okay? Now, let's talk about classification of cyclones. This is very important, okay? Now remember this thing, that these tropical cyclones are called by different names, okay? These tropical cyclones are called by different names. In the Indian Ocean region, they are called tropical cyclones. In the Atlantic Ocean near America, they are called hurricanes. In the Pacific Ocean near China and all, they are called typhoons. And around Australia, they are called willy-willies. These names are given in your notes, don't worry. Now, some storms are powerful, some storms are not that powerful. So based on the intensity of a storm, based on the speed of the wind in a storm, okay, these cyclones are classified into different categories: severe cyclonic storm, very severe cyclonic storm, extremely severe cyclonic storm. So there are these categories, okay. So let's talk about classification of cyclones. So tropical cyclones are classified into different types, mainly based on their intensity, wind speed, and regional naming convention. So for Atlantic Ocean, there is different categorization, okay, which is known as Saffir-Simpson hurricane wind scale. So whenever there is a tropical cyclone which is called a hurricane near America or Caribbeans, well, its categorization is done by Saffir-Simpson hurricane scale, okay. If there is a typhoon in Pacific Ocean, for that there is Hong Kong Observatory. And if the tropical cyclone is in the Indian Ocean region, its classification is done by Indian Meteorological Department, okay. So let's talk about these scales. We won't talk about Hong Kong Observatory because these two categorizations are in the news generally. Therefore, we'll talk about these two only, Saffir-Simpson and IMD. So first, let's talk about Saffir-Simpson wind scale. So each cyclonic storm is divided into 5 categories based on their wind speed. So if it is a category 1 storm, it is of low wind speed, it will cause minimal damage. Category 2, some more damage. Category 3, strong storm. Category 4, very strong storm. And category 5, very severe cyclone. Okay, so as soon as you increase categories, well, that means that the cyclone is very powerful. Okay, so you must be hearing about this in the news. When India was playing the World Cup in USA, okay, there was this hurricane also that hit the Caribbean islands. Okay, that was called a category 4 storm. So you must be hearing about this in the news if you're following American news. Okay, so hurricanes are categorized as, well, in these categories. So category 1, category 2, category 3, category 4. Okay. Then there is also this Hong Kong Observatory. It has 6 categories. Okay. And then there is this, our Indian Ocean region categorization. Okay. So in Indian Ocean region, Indian Meteorological Department categorizes storms in these categories. So if the speed is between 31 to 50 km per hour, the wind speed, it is a depression. If it is 51 to 62, deep depression. 63 to 88, cyclonic storm. Then severe cyclonic storm, very severe, extremely severe, and then there is the highest, the most dangerous storm, super cyclonic storm. Okay, so remember this categorization as well. It is given in detail in your notes, so do memorize your notes as well. Okay, now let's talk about certain more features of a tropical cyclone. In brief, we talked about these features like eye of the storm, eye wall, rain bands, all these things. Let's talk about them in a little more detail. Okay, so characteristics and features of a storm. So number one is the eye. So it is a small, well-defined circular or oval area at the center of the cyclone. Calm weather, clear skies and low atmospheric pressure is its feature, okay, is its characteristics. Generally, the eye of the storm has a diameter from 8 to 50 kilometers. Okay, the eye forms due to descending air. So when air rises up, it forms clouds. Clouds move outwards, and this dry air, whose moisture has been taken away, comes downwards because it is cool now. When it rises up in the height, it cools down and then comes downwards. So this descending air is seen in that area. This is the eye of the storm. Then the destructive part, eye wall, surrounds the eye and is the most violent and destructive part of the cyclone, composed of towering cumulonimbus clouds. So this eye wall contains clouds which are deep, like they have a huge height. I mean, they have height. Okay, these clouds are dark, full of moisture, and they have a very, I mean, their height is huge. Okay, these are called cumulonimbus clouds. You must have studied about clouds, different types of clouds. So the most powerful clouds are cumulonimbus clouds and intense thunderstorms. Wind speeds are strongest here, often exceeding 250 kilometers per hour in severe storms. Heavy rainfall, storm surge occurs in this region, causing significant damage. Okay. Then there is vertical structure. So if you take a look at this storm, okay, there is this vertical structure. It is divided into three parts. This part, the lower part, middle part, higher part. Okay. So let's talk about this vertical structure. So it is composed of three layers. The lower layer, inflow layer, up to 3 kilometer height, where air converges, air from all directions comes and rises upwards. Then main cyclonic storm, 3 kilometer to 7 kilometer in height. And outflow layer. At the height of 7 kilometer, the air spreads outwards along with the clouds. So clouds are spreading outwards. This is the vertical structure. Okay, inflow layer, main cyclonic storm, outflow layer at the top. And then there is spiral rain bands. So as you can see, this is the eye of the storm. This is the eye wall. And then because the clouds are moving outwards, they form spiral rain bands, which cause rain. This is spiral rain bands, these. Spiral shaped bands of thunderstorms extending outward from the eye wall. These bands spiral into cyclone center and are associated with heavy rainfall, gusty winds. They can cause localized flooding and wind damage. Okay. And then there are certain other features which are given in your notes. So for example, tropical cyclones in the northern hemisphere, their direction of movement, their rotation movement is anti-clockwise. Question can be asked, so pay close attention. Okay. Then tropical cyclones in the southern region near Australia, okay, Willy Willies, they rotate in a clockwise fashion. Okay. So this is one feature. Then there are so many other small features which are given in your notes. So do check them out. Okay. All right. Now let's talk about a very important thing. Because when you follow news, you must have heard this, that cyclone Namdafa is approaching, cyclone Meluha is coming. Okay. They always name a cyclone. Every cyclone or a hurricane or a typhoon has a name. Okay. Now, what is the process of naming these cyclones? Who names these cyclones? There is a proper systematic thing that runs in the background which gives these cyclones their names. So what is that system? Okay. So let's talk about naming of a cyclone. So the naming system is regionally coordinated and standardized by World Meteorological Organization, okay, and its regional bodies. So World Meteorological Organization has regional bodies which coordinate the naming system. So for example, there is a regional body in Atlantic Ocean, regional body in Pacific Ocean, regional body in the Northern Indian Ocean, Bay of Bengal or Arabian Sea, all of this, okay. So different ocean basins have regional meteorological organizations that maintain rotating lists of names approved by WMO. Names are chosen sequentially. So at the beginning of every year or at the beginning, in the beginning, they create a list of names. And then whenever a new storm comes, new cyclone comes, as per the sequence, it is given that name. Names are chosen sequentially from predetermined lists that rotate every few years. Okay. The systems alternate between male and female names. This generally happens. Okay. So this list contains male names, female names, and it alternates between male and female names. Okay. The list generally avoid Q, U, X, Y, Z letters. Okay. The storms, you'll generally see that the cyclonic storms are not named or are not given names which start with either Q, U, X, Y, Z. That is generally the case. Okay. Now let's talk about these regional bodies. Okay. So regional bodies. Let me change the color. Okay. So for North Atlantic Ocean, there is WMO-RA. For North Indian Ocean, the designation is with Indian Meteorological Department, not any other country. IMD is the regional body for North Indian Ocean. For Western Pacific, it's Typhoon Committee. For Australian region, it's Bureau of Meteorology, Australia. Okay. Now, what happens in case of India? So let's talk about India. We'll only focus on India. Just remember these names for different regions. Now, what happens in India? Criteria in the Indian Ocean region. So IMD is given the regional, IMD is designated as the regional authority for Indian Ocean. Okay. So what happens is that IMD operates as one of the 6 RSMCs, regional meteorological organizations globally, and works with 12 countries. Okay, 12, 13 countries are there. So around 13 countries are there, not 12 countries, 13 countries are there which submit the names. So there are 13 countries surrounding the Indian Ocean region. They submit their own names. They submit 13 names. So every one country submits 13 names. So 13 countries submitting 13 names, total 169 names are compiled, and IMD keeps a list. Member countries submit names to WMO ESCAP, Economic and Social Council of Asia Pacific Panel on Tropical Cyclones, which creates a combined list of 169 names. The IMD selects the next name from the list in a pre-assigned sequence whenever a tropical cyclone forms. So this is the system. Just remember, IMD is the regional organization for WMO in the Indian Ocean region. Okay. So this is the naming criteria. Now, the thing is that we have talked about this, that IMD is the authority in the Indian Ocean region. Especially they said that is the authority in the Northern Indian Ocean, right? Now, North Indian Ocean has 2 seas, Arabian Sea in the western portion and Bay of Bengal in the eastern side. Now, it is generally said that though Arabian Sea is also a sea, but most tropical cyclones, around 2/3 tropical cyclones, occur in Bay of Bengal. Bay of Bengal is more prone to tropical cyclones than Arabian Sea. Very rarely you will find tropical cyclones in Arabian Sea. More than 66% of tropical cyclones occur in Bay of Bengal. Why? They can ask a question. So why? So why more tropical cyclones in Bay of Bengal? First of all, Bay of Bengal is more warmer. The Bay of Bengal, being more enclosed, has warmer waters than relatively open Arabian Sea. Plus, well, Arabian Sea also is, let's not say victim to, but downwater upwelling happens in Arabian Sea. So it is relatively cooler. As you all know, warmer sea is a prerequisite for tropical cyclones. Then higher moisture content. Bay of Bengal receives abundant moisture from surrounding land masses and the monsoon, creating favorable humid conditions. Geographical enclosure. Bay of Bengal is more closed. Arabian Sea is more open. So moisture is basically condensed, or moisture is basically enclosed in a small space. Strong wind shear, yes. Arabian Sea has strong wind shear, whereas the prerequisite is low vertical wind shear. So this is the problem with Arabian Sea. Plus, dry winds from Sahara Desert or Arabia, Saudi Arabia, Oman, dry winds from there blow into the Arabian Sea. These are dry winds from the Arabian deserts. They reduce the moisture content also. So this is why. Clear? So that's all you need to know. By the way, in your notes, some extra information is also mentioned. The impact, the devastation caused by tropical cyclones, and how can we save more lives, mitigation. This is given in your notes, so do check that out. All right. And that would be all. With that, we conclude today's session. So thank you so much for watching, everyone. And I'm sure it has added value to your preparation. But it will add more value if you will revise and memorize this lecture, ask your doubts, and be regular with the test. For that, you would have to register on our app or on our website. The links to both are given in the comment section below. So do that, and I shall see you next time with another topic in this lecture series called Prelims Powerplay. Thank you, everyone.